Let's see how a stack internally works. So, stack generally uses last in, first out type of principle. So, such that each and every time, take for example, it's a stack. So, I'm going to add an element inside the stack. I'm going to add 10 in the sense. After that, after adding 10, I'm going to add one more element 20. So the element that I can be able to fetch first is 20, and then only I can be able to fetch 10. Even though I have pushed 10 and 20, 10 at the first and 20 at the last. So, but the element that has been popped first is the last element. That's why we are naming it as last in, first out. And here we will be having two different type of operations. One is push operation. Generally, push operation is we will be having an element. Take for example 20 in the sense that particular element has to be added in our stack. That's what we will be calling it as a push type of operation. And we will be having pop operation, which is nothing but the topmost element of the stack can be removed. That's what we will be calling it as a pop type of operation. Here as well, similar to queue and in stack, we will be having the common operation. Take for example, if we have push operation, in this case, in this scenario, we are going to insert some element inside the queue. Sorry, inside the stack. So in this case, if the stack is already full, we cannot be able to add a new element inside the stack, right? So if it is full, if full, so the program has to be terminated. What about pop operation? When if the stack is empty already, there is no element inside the stack, and we were supposed to remove an element from the stack. So if empty, so if empty, the program has to be terminated. These are all the two scenarios that we will be taking inside the stack. Other than these two scenarios, if any of the half partially any elements are filled inside the stack, in this case, or even if the stack is empty, so we can be able to add a new element in this case. So we have to write operation according to this condition. Here as well, if we have the queue as if we have this particular stack as filled or it is partially filled, we can be able to remove an element from the stack. So for this, we have to write two types of conditions. Let's jump into the program and let's try to execute how the stack will be actually working. In this program, we have a normal main class. Here, let's try to implement a stack. Generally, stack is equal to new stack. I'm going to create a stack here. We know that we can be able to make two operations. So push is one of the operation and we have pop operation. Generally, for for inserting a new element inside the stack, it is definitely necessary to give the actual element that has to be pushed inside the stack. So we have to define it. For popping, by default, the topmost element only will be popped. So we don't need to specify which element we need to pop. So that's why I haven't defined any integer here, but definitely we have to define some numbers over here. And we have an object, right? So that object access should be there. So stack dot push. So this operation has to be done. And stack dot pop. Okay, so as we have these two operations, I will make some more operations as well. So stack dot push of 20, and I will be having one more other stack operation, stack dot pop. So here, imagine in the situation I have pushed two elements and I have popped it, right? And take for example, if the stack particularly is empty in the sense, so we can be able to give one condition like if stack is empty. So if it is empty, so we have to print stack is empty. Why? Because we cannot be able to understand if simply the program will be getting abruptly cut, because what operation may be internally taking place we cannot be able to understand. So that's why I'm just declaring if stack is empty. So I will be just giving a sysout statement that actually executes that the stack is empty, and the program has to be terminated. We can be able to give sysout system.exit after this sysout, or else it is even not necessary, because as the main program itself will be completed, it's not necessary over here. Else we can give sysout of stack is not empty. These are the two statements that we can be able to execute. Okay, so here if we need to see the topmost element which is actually present, so how can we be able to see that the top element? So which is the topmost element which is present inside the stack? Here we will be having peak. So peak is the topmost element that we will be having inside the stack. And we will be having one more operation, likewise stack.push, stack.peak, stack.pop. We will be also having stack.size. So which actually defines the size of the stack. We can give a sysop statement for this as well. Else the stack is not empty. That's it. Let's write down the class stack. So in general, take for example, we haven't even imported this, but by default, the stack has been implemented. But now what we are going to do is we are going to develop this program. So that's why we can remove this. See how much error that comes after this. So we are going to define this stack class. Class stack. Here, this the value, like the stack has been defined over here, and we are going to define some of the internal attributes of the stack. And we know that what are the basic operations that we will be making. One is push operation, public void push, which makes integer x. Here, if the element is full in the sense, here what we will be doing, the elements are of the stack cannot be included inside the stack. As the stack is already full, we cannot be able to add a new element inside the stack. That's what we have to give it. So stack full, no adding. That's it. So we can even say it as overflow. If it is overflow, definitely we have to give system.exit of -1. So we can be able to define any other constants. This will be actually, we can be able to see it in the runtime. Again, we have seen one more condition. If it is not full, if it is partially filled, the stack is partially filled in the sense, we can be able to, there is a possibility that we can be able to add one more element inside the queue. If it is partially filled, definitely. So here we have to give, we are about to insert an element. So inserting of what element? So we have to define a temporary variable over here. What is the value that which we have given here? It is x. So we can be able to tell like we are going to insert a new element x over here that we have defined over here. And the array will be increased to the element. Take for example, consider a situation here. Uh, Here I have a stack. So within the stack, I'm going to add some element so such that here the array will be 0, and if we were about to add a new element, so this value has to be increased. The top element has to be increased. So how we can be able to define it in a sense? array of top is equal to x. So that's what we are going to update the topmost element. We have to define all these values. That's why it's showing in red actually. However, we have completed the push operation and we are going to make pop operation. So public integer pop, so which generally consisting of if the element is empty, the sense we have to give its overflow, right? So if any of the element is pushed inside the stack, then it is, and if we were trying to make any other element to be added inside the stack, it is overflow. Already there is no element inside the stack, and we were about to pop any element in from the stack in the sense it's underflow. We can be able to say like sort of simply underflow. The program has to be terminated. System.exit of -1. After this, we have this scenario. Take for example, if after this condition, so we can be able to remove an element. So just simply print, we are going to remove an element. So sort of removing of what element, the topmost element. So we don't know which element it is. So just simply give removing. And if we would like to know which element we are going to remove in the sense, we can use a word. Take for example, peak. So peak, what it will do is it will actually peak could be able to bring out or get the topmost element from the stack. So that's what the peak operation will be actually doing. So we can simply give it as peak. What it will return? So the return operation is array of top minus minus because we are about to pop an element. So such that in the previous case, 0 has been added to 1. Here already the element has been removed. So such that 1 has to be reduced to 0. That's what we will be giving it in the written statement here. As of now, we have seen two different operations. One is push operation and the other is pop operation. So we will be doing all these types of things. Let's try to implement peak operation, which we have mentioned over here. What is peak generally? Peak can be able to fetch the topmost element of the stack. That's it. So it will definitely return an integer. So I'm going to give return an integer of return type. Here is not if it is not empty in the sense, so then only this operation should be taking place. In this case, it should return some values. If not, take for example, if the stack itself is empty, the stack generally itself is empty and we were trying to take the topmost element of the stack, it is also not possible, right? So here that's what we are going to return, write it in the else condition. What about if it is not empty? We are going to return the array. Take for example, I have 20 over and 10. In this case the stack is not empty, right? So I'm going to remove the topmost element, which is nothing but array of top topmost element. So I'm going to return the value. Return array of top value, else we have to return system.exit, right? So it's not even returning. So we can be able to give system.exit of -1. That's it. So we have written some values and after this operation will be taking place, by default we will be giving a return -1. Program exited with this particular code. So we are going to give return -1. In this particular stack, class stack, we are supposed to create some constructor. Take for example, stack of size. As because we have created a new stack, we have to define it on the basis of size. And what are all the attributes which has to be present inside the size? It is an array of elements, so through which we will be inserting some of the elements, and we will be having a capacity, and we will be also having the topmost element, because all the operations will be taking place only from one end in the case of stack. Only one end we will be taking, and it is the topmost end. So that's why I have given the three elements only will be there. One is the array, and the capacity of that particular stack will be given, and the topmost element will be taken into consideration. In general, so take for example, in an empty stack, by default, we will be returning it as -1, because the topmost will be -1. If a new element has been added inside the stack, the -1 will be converted to 0, and then the topmost will be 0. Again, if any more other elements will be added, it will be actually getting increased. So that's why we will be just for the first initial time, we will be declaring it as -1. And coming to capacity, capacity is nothing but the size of the stack. That's it. So size, we have to declare it. The size has to be declared as the capacity of the stack. And what about the array? It is nothing but new integer which is of size. Okay, so we have to declare it. This is the small constructor that we have created, and we have to define all these types of variables. So I'll declare it private over here. Why? Because I have created a constructor, so that's why I'll declare all these variables as private. Private int array. So all the values, see, there is an error, but it got rectified here now. So, okay. And then we will be having a private in capacity, and we will be also having top element. That's it. So we have, as of now, we have completed the push operation, and then we have also completed pop operation, and after that we have completed the main operation as well. Here, as soon as we have created push and pop operation, size is empty has also should be defined. So for that, size of the stack, and then if the stack is empty, what we need to do, and then if the stack is full, what we need to do. These are all the three operations that we need to declare. Here, take for example, if the stack size for this particular function, what we need to do is we have to return a plus plus. So such that, take for example, the dynamic size of the stack will be totally depending upon here. Take for example, the stack, the particular stack's size will be totally depending upon the top value. So here, initially the top value will be -1. So after that, the top value will be becoming 0, and then the top value will be becoming 1. So such that, take for example, uh, as of now, we will be continuing it. So initially it will be -1, and I'm going to add 10. So such that top will be 0. And I'm going to add 20 in the same stack. So such that the top value will be becoming 1. So what will be the size of the stack then? Size will be top plus plus, right? So plus plus top. That's what we have written over here. So written top plus plus should be the size of the stack. And considering if it is empty, so generally how we can be able to declare it? Public Boolean, right? So each and every values like this has to be declared via a Boolean value, which generally states that if it is empty, we know that the default value that we have given is -1. So this has to be if the top value is -1, then the stack will be empty, so we have to return it. If the stack is full, then it should be validated to the size of the array, right? So return top is equal to capacity minus 1, right? So that's what. So top is equal to capacity minus 1. So which is nothing but we know that the top will be actually validated from minus 1, but the capacity is from 0, right? A new element will be added in the sense 0 plus 1. So first element will be added in the sense other capacity will be 1. So that's why we are validating via this. Let's try to execute this program. I think we have to add if condition. Let's run the main program. Okay, it's showing some error that we need to declare the size of the stack. I'll declare it as 3. Let's run it again. Okay, it's showing some values. So within which here within our stack, we have just now inserted a value 10. 10 has been inserted first and then 20, and we are going to so such that we are going to check the peak value here. Peak value should be the topmost element of the stack, so such that 20 will be returned. After that, we are going to remove an element, so such that 0th index value will be removed. So, and then 10 will be removed, and then if we check the update, then the stack will be empty. That's what they have printed. That's it. So this is how we can be able to implement the stack.